Welcome everyone to Friday Office Hours. We're really excited you're here today. My name is Anna Shavers, and I am the Senior Communication Specialist at the All of Us Data and Research Center. As many of you know, SAS released to the Researcher Workbench back in April, and today's Friday Office Hours will actually focus on how to use SAS for data analysis in the Researcher Workbench. For this presentation, feel free to ask questions. Aymone has graciously offered to answer questions related to slides. So if she's going through something and you have a question related to that slide, just raise your virtual hand or come off mute and we can answer those questions if it's related to what Aymone is showing in that moment. If you do have other questions related to the program or unrelated topics, please drop those in the chat or hold those until the end when we actually open it up for a Q&A session. You also note we are recording this session and we'll post that video recording within about 1 to 2 weeks on our user support hub and on the YouTube channel. Before I actually introduce Aymone today, I do have a couple of announcements to share. There we go. First, the Aim Ahead All of Us training program is seeking mentors. For those of you who don't know, the goal of Aim Ahead The Aim Ahead program is to increase researcher diversity in artificial intelligence and machine learning. Mentors should be active investigators in the proposed research area. So if you are interested in serving as a mentor, you can check out more information on Aim Ahead's website listed there or by using the QR code here to the right. Just a note, applications are open now and they are due by January 6th. Okay. Next, the Interdisciplinary Guided Network for Investigation, Translation, and Equity, or as many of you probably know it, IGNITE, is offering a virtual training opportunity for biostatisticians to learn about the All of Us Researcher Workbench. The training will take place on January 16th and 17th, and you need to apply by January 10th. You can view more information and apply by using that QR code. And last but not least, the application for the All of Us Evenings with Genetics Research Program's Biomedical Researcher Faculty Summit, mouthful, is now live. The summit is designed to train early career researchers to access and utilize the All of Us Researcher Workbench. The program seeks to engage early stage investigators and postdoc candidates, including those from groups that have been underserved in the biomedical research workforce. The summit will be held in May 14th, May 17th in Houston, Texas. If you're interested, you will need to submit your application though by February 28th. You can view more information and apply using the QR code here. So a lot of fun activities coming up early next year with deadlines and everything there. So we're excited to have Aymone join us. Aymone is a data science expert from the All of Us Data and Research Center, where she leads the data science and engineering efforts for the digital health technologies. For today's presentation, she is going to be utilizing her expertise with SAS in the Researcher Workbench. She actually recently attended the American Public Health Association annual meeting to present on data analysis with SAS in the Researcher Workbench. So she is super knowledgeable in this area and we're excited to have her. She is involved in the back end and front end processes of the curated data repository, working closely with the curation team and the research support team. Aymone discovered her passion for data science after a few years working and studying in business and accounting, and she holds master degrees of science in data analytics, information systems, accounting, and business management. Before joining our team, she worked on the data science team of a cybersecurity company. We're so excited you're here, Aymone. And with that, I will actually stop sharing and hand it over to you.
Thank you so much. I will share my screen now. And share. I hope everyone can see my screen now. Good.
Yes.
So, welcome everyone, and I hope everyone is doing well. Today, we're going to do a hands-on demonstration of analyzing data in SAS Studio, and we'll go through a bit of data collection. I'm going to explain a little bit in general what's happening with the code and go through some tips, but we'll spend most of our time doing data wrangling, and I'm really trying to address some issues or problems or questions that we frequently get from our researchers. And then throughout this session, as well as at the end, I will give you some tips to avoid or resolve certain issues that you may have with code or the environment in SAS Studio. And because this is a recorded session that will be published, we're going to use synthetic data, but the code that I'm sharing and I have copied and pasted it in prod in the real researcher workbench, and it works fine. And actually all of the workspace, the code that I'm using comes from the community workspace that I published, and that is the presentation that I did at the APHA workshop. And in that, I'm querying and wrangling a lot of data, 6 data sets. We're going to focus on 2 today because I had 4 hours and I have only 1 hour here-ish. And I did a bunch of data wrangling in there. I wrote some macros to do some demographic characterization, some statistics on continuous variable, and so on and so forth. So if you're looking to doing something in SAS and you're trying to figure out the best, most efficient way to do it, check this community workspace there. And with that, let's get into SAS. I'm going to stop sharing this one and share my screen in SAS. Yes, in my screen. Okay, hope everyone is seeing. Oh, I think are you seeing the SAS?
Yes.
SAS Studio? Okay, cool. Yeah, so we'll start with the data collection. We won't go through the process of the core builder and dataset builder just because I want to focus on the data wrangling, and we do have resources to help you do that. But after you constructed your query in the dataset builder and you copied it, this is where you would paste it. You can just click on new when you open SAS and then new SAS program and just pasted it. That's exactly what I've done. And I just added some text for explanation and context. So like I mentioned, we're going to work with 2 data sets, survey data, which is one that is a little more tricky for our researchers. And then we're going to work with physical measurement data. In the community workspace that I shared, I'm also working with a diabetes data set and controls data set and other data sets there. And so what we're going to do is I already ran the code, but I'm going to walk through the code. And you can also write your own SQL query here if you know SQL. One thing that I want to mention before we start is that a question that we get is sometimes people will say that the code takes a long time to run. I've heard 30 minutes, 90 minutes for just a SQL code. This shouldn't be. What is happening likely is that your code isn't running. So when you run code in SAS, you should be able to see the log here moving. There should be some movement happening. So let's say I run this. It might take a few minutes, but something will happen. And if nothing is happening after 5-6 minutes, then your code is not actually running and the server is stuck or your session ended for some reason. What you need to do is to close the program. You can also close the entire workspace, but so far just closing the program has helped. And then open it back up and then your code should run. This entire data collection, took 3 minutes in here, and in prod, because I ran this in a real data set, it took 5 minutes. So 30 minutes is too long. So that's tip 1. And then, so let me explain at a high level what's happening with the SAS code. So just like with R or Python, we need a way for SAS to locate the all of us CDR within the Google BigQuery dataset, because this is where the CDR lives. And so this environment variable is what's going to help us to do that, to locate the specific address of the dataset there. And then we also need to wrap our code with SAS code here. If it's in Python, we wrap it with Python code. If it's R code. So the SQL code itself doesn't change. So if you were to use to grab the same cohort in Python, the SQL code would be the same, but then you will see Python code wrapped around. And of course, the environment variables will be different. So that's with that. And here where I'm just printing out. So I already ran this. I'm just going to print out this data set to show you what it looks like. So this is the survey data, and this is what the first 5 rows, again, this is synthetic data. This is what the first 5 rows look like, and this is the count of participants. So I ran this in a real data set, and that was basically every participant, 413,000 people with about 2,900,000 rows. So it's a substantial data collection process that still took about 5 minutes. So this is the first one. And then the second one is physical measurement data. Again, the same concept. The SQL code would change, of course, but basically the code that surround is the same. So that's also helpful for you if you want to write your own query. All you need to do is to change the SQL code in between and then keep everything else around. And this one, if we want to run, I'm just using proc print to print the first type observation, and then with proc SQL, I'm using to count the number of participants, and then proc contents gives us, the number of observation, that is the number of rows, and then this is the number of participants, and then the first 5 rows. And in the real CDR, this is what we have, about 1 million row, and then 282,000 participants. And then the next thing that we're doing is we're saving this to the persistent disk, to our environment, and to the bucket. Now, this is another tip. If you are working on a full analysis, I recommend splitting it into multiple SAS programs, so you can have one program for collection like I did here and one for wrangling. That is helpful to avoid performance issues, to avoid your program to crash. Even in R and Python, it's not advisable for you to do all of your analysis in one notebook or one R file, because the potential of the code crashing is higher. And to help you do that, you can take advantage of the bucket. So if you save your file to with just proc export like we did here, it's going to be saved in your environment, but only you can have access to it. So people who are in your bucket cannot, in your workspace, who share your workspace, cannot see that. And also, if you delete your persistent disk, as you should, if you're not going to be using it for a long period of time, to save costs, you may want to delete it, then the file will be gone. But if you save it to the bucket, what can happen is that first, when you start your analysis again, you don't have to rerun the whole data collection again. You can just grab the CSV file from the bucket. And also, the file will exist there permanently as long as the workspace exists. And also, anybody else in your team that shares the workspace can just grab the file and work. So somebody can grab the file from the bucket within RStudio or Python, or they can write a file from Python. Let's say they collected the data and need some wrangling in Python and they save it to the bucket. You can grab it from SAS Studio and do some statistical analysis on it. You don't have to run their whole code again. So this is what I'm doing here. Using proc export, I'm saving the different data that I had as different CSVs. So actually this one is not, we're not using this one. As data underscore PM for the physical measurement, and data underscore survey for the CSV. So that's step one. And then from that, you can now grab the file in a persistent disk and then save it in the bucket. There are a couple of ways to do it. If you have multiple files to save, you can list them out. So you will need to use a gsutil copy command to do that. And you don't need to remember this by heart. We have articles for that, but the only thing that you need to change really is the names of your file. Everything else will remain the same. So you can list all of the files after the copy command separated by a space, and then it'll go in the bucket folder data. Or you can use a wildcard like I'm doing here. You notice all my files start with data underscore. So I'm saying, hey, grab any file in my persistent disk that starts with data underscore and it ends with that CSV. And then you can save it in a batch like that. Or you can do it one at a time like I'm doing here. I also included here code to remove file. Be careful if you delete a file from the bucket, it's gone permanently, but you may want to remove file that maybe you didn't intend to save or you don't need anymore. So you can use that code. You can use gsutil remove. So that one's just util copy. And then you have just util ls, which lists the file that you have in the bucket. We can run that. And while that's running, lastly, actually it should be quick. There you go. So these are all the files that we just saved. I had saved this earlier in the bucket, and that's available for anybody that's shared the workspace to grab and use. And then, so this is an optional code that I use to grab the time it takes to run the file. So at the very beginning here, I have this code that captures the start time. And then at the end, this code captures the end time and then calculates the total time it took to run the file. That's how I know that this took 3 minutes. Okay, so this is for the data collection, and we're gonna go into the wrangling. So here we have our files in the bucket, and then we can come back another day, and then we can grab it back from the bucket and read it into it. So the whole data wrangling here took 5 minutes and then about 8 minutes in prod. And I'm doing a lot of computationally intensive things here. So again, if your code takes 30 minutes for just a regular SAS file, then maybe something is wrong. So here we're going to do various things. We're going to do some string manipulation. We're going to do some pivoting, so turning from long to wide, and other wrangling in practical. So if you already have your file in a persistent disk like I have right now, because I didn't delete it, you don't have to go from the bucket. You can just use proc import to read it back. But if you do, then you can use yes to copy, but then you switch the order. Instead of the PD to the bucket, is now the bucket to the PD into the bucket to the PD. And then you can just copy the file that way. And so I commented this out because I don't need to use it now. And then we can read our files back. So actually, let me go back here and explain a few things that might trip you up, and questions that we had regarding certain warnings that you get when you run a query directly from the code builder. So this line of code right here, so when you get the code, this line of code will appear as well, and you will get this warning message. This is just a warning about a library not being assigned in the code. It doesn't affect the code at all. It doesn't change anything. Your data is fine. If it bothers you, you can comment it out so it doesn't do anything. And then you might get this error that is related to proc print. Oh, a warning, not an error. It's very different. If it's an error, your code is not going to run. Warning, data too long for column, blah, blah, blah. It's not saying that your data is being truncated. It's just a displaying of it. SAS can't display the number of characters that you're wanting, but your data itself is fine. So this is not concerning. I just wanted to point these two out. And because that also relates to proc import. When you import data, especially with the survey, all of our survey that have very long strings like this, what can happen is that SAS most likely will truncate some of them. So it might cut it right here, and then you won't see very important part of the cells that tells you information about the data. So a way to avoid that is to use guessing rows when you import data into a SAS program, and you can change the number up and down depending on how it looks. So you can use this proxical. I'm just looking at the unique question and answer string values to see if that looks okay. And then if it doesn't, you can change. And what guessing rows does, it looks at the first 50,000 rows here of the data, and then it looks at the longest string in that and use that as a standard to truncate or not your data. That's high level what's happening here. So use guessing rules for survey, especially also physical measurement, because it does have some long strings. And so this is what the data looks like, and that looks correct. All the strings seems to be there. And then we did the same thing for the physical measurement. And now we're gonna go into the data wrangling. So we're going to wrangle now the survey data. What we're going to do here, we're going to do some string cleaning. We're not going to do age calculation, but it's available in the community workspace that I shared. And we're not going to do that. It's in the community workspace. But we're going to do some joins and pivot, so turning from long to wide, and then some other wrangling proxy. Let me explain also the difference between SQL that you see here and then SQL that you get when you import a data set from, like a query from the dataset builder. So this is connecting to an external database. It's connecting to BigQuery to grab data from BigQuery. This is just SAS code mimicking SQL syntax. So it's not actually connecting to anything. And the difference is important because some things that can work in SQL in BigQuery, for example, may not work in just SAS SQL. Most things work, but there is a really cool function called string aggregate that I will talk about more later that works in Google BigQuery here. So it would work if I used it here, but if I try to use it here, it's not gonna work. So if something like this happens, you're not doing something wrong, it's because this isn't actually like SQL. It's SAS, it's still SAS code mimicking SQL syntax. So we're using SQL, but it's very useful and very efficient for a lot of wrangling, and that's actually the default. If you know SQL syntax, I would advise using that, but I'll show you both ways in this notebook. So I'm just looking at the distinct values again because this is what we want to clean up. So because the strings are very long and we want to pivot, we want to use this column as our new column in the long format. We need to wrangle it because if we try to pivot it like this, SAS won't like it. SAS will get sassy. So we need to do some wrangling here. As a researcher, you need to figure out what is the best way to clean the string to remove information that isn't actually necessary, but to make it so that the value provide information about what's happening in this data. So here, for example, I decided that I will remove, this because I don't need this. I just need to know that it's sex at birth. And for the answers, I don't need this. I just need the answer, just female. And the same thing for grade and employment. And then for this, the family's history of diseases, I want to remove this. I just want to keep the disease and I want to keep the family member that has the disease. That's all I want to keep. And then other ones are a little bit more tricky because this one doesn't, if I remove this, the overall health, this doesn't really tell me much. So I want to actually change that with something else. The question is, I think, how often, how well can you carry everyday activity? So I want the title of my column, because this is going to be turned into a column name, to be reflective of the information. So I'm going to change that, and then I'm just going to keep this answer. And then for race ethnicity, I'm just going to keep race. So here's how we're going to do this. We're going to use the data step to replace specific string with specific string. So if you want to replace a string value in a column, you can use this function. So here I'm creating a new column and then replacing this value here in that column. I say if you find any value in that column that's exactly this, replace it with just, no space. So it's going to basically erase it. So it's going to replace everything. It's going to erase this part of every instances here. And then the second thing here is for everyday activities, I want to replace it with the name can carry daily activities, because I think that's informative about what's happening. And then for general physical health, I just replace the space with underscore, and I'm actually going to do that with every value in here, as you will see later, because when we transform these into column names, it's gonna just avoid a lot of wrangling issues if you replace all the spaces in between the words with underscore. And then again, we're gonna remove the first part of that question too, and just erase that. And then for race ethnicity, we just want to keep race. And then another way to clean string is to replace, or you can keep strings that appear after or before a specific character. Here, I want to only keep the string that appear after this character and this character in both the question and the answer. So I want to only keep this, and I want to only keep that. So you kind of have to be creative with the code about how you can wrangle this in a succinct way, so you don't have to write 50 lines of codes and do it all at once, basically. So now let's look at the result of all of that. And this is what we get. So we have the answers and then the question nicely cleaned, but we still now want to replace the spaces with underscore. This is what this does. This translate here, replace all the empty spaces with underscore, and the trim and strip, they remove the trailing spaces, the blank spaces, so maybe we don't replace all the space after or before, if there are any, with underscore as well, just the ones in between. And then this is what we get. Now we have values that can be easily transformed into columns, and SAS will be happy. So now we try to pivot, but this code will return an error. Why? Because that is typical. And I put that error on purpose. So if you get this, you know how to fix it. It's because we have questions with multiple choice answers. So in SAS's mind, you have duplicate data. It doesn't want to pivot with duplicate data. And this is an easy way to check with proc SQL. So I'm counting here the unique number of participants, and I'm counting the row. So the row counts per question. So you can see here that the row count per person is higher than the number of unique person ID per question. So that tells you that for this question, employment status, there are people who have multiple answers. And it's normal because it's a multiple choice answer question. And same thing for race. Everything else is the same number. So those two are the reason why we're getting an error in our data, actually for type 2 diabetes as well, and type 1 diabetes, whoops, and autoimmune diabetes. Okay, so there are a bunch of them that are causing this error, and we can fix that with the deduplication process. Now, if you know SQL, like as in BigQuery SQL, you could do that with string aggregate, which makes it easier. In Python and R also, that is a pretty easy thing to do. In SAS, it was a little bit tricky, but this code will do that for you. First, we are sorting the data, and I will explain later why I'm sorting by answer as well. But we're sorting the data, and then using this data step, we're first creating a new data frame called survey dedupe, and then we're creating a new column where we'll place our new variables. And I forgot to explain this. Sorry. If you have duplicate variables, this is up to you as a researcher to figure out how you want to fix that for surveys. So some researchers can say, okay, I'm just gonna recode or create a new variable. Let's say somebody says employed for wage, and also they insert non-employed. So the researcher can say, okay, this is just going to be employed. That's how I'm going to code this. So you can do that. So you can do it any way that you want. But for this purpose, what I'm going to do is I'm going to concatenate all the answers and separate them by a comma per person and per question. So this is what I'm doing here. So all answers will include all the concatenated answers. And then for each person ID, this is essentially doing, if you can think of it that way, a group by person ID in question, and it concatenating the answers or separating the answer by a comma. And then because I'm creating a new column, I don't need this old column. I'm just going to drop it. And let's see what that looks like here. And yes, we can't really see. Let's run this one. you're gonna see now we have the same count of rows as count of unique participants. Yeah, so now we have the same count. That means that everything is one row, one row per person, and we can pivot now. And then you can see the concatenation that I did. So the reason why I wanted to order by person ID question and answer is because I didn't want to create two groups for the same thing. So if I didn't order by answer as well, I could have had a group that said daughter, father, and one that said father, daughter. Like it's the same thing, it's just sorted, it's not sorted. So if you sort it, then it'll belong to the same group. So that's why I did it both ways. And then now we can pivot. And after we pivot, I already ran this before. So I'm just going to show you the result of what we get. So this is the first 5 rows of what we get. And then this is me just showing you for employment status, for example, the counts that we get. These people have both answers, and these have only one answer, and these didn't have answers. You can also, if that bothers you, there are blank spaces because these questions are not required for every participant. They're basics. So you will see some people in the pivoted data don't have data for these. That's normal. You can do an if else to replace it with no answer or whatever you want, but we won't do that today. So this is our pivoted data, and this is how you would fix this duplicate issue that you often get with long to wide. Now let's talk about wrangling physical measurement. We're going to try and do it with proc SQL. Again, this is just SAS code that mimics SQL syntax. And that's typically very efficient for intensive processes. So if you know that, that will be the default that you could use. So here, let's view the data that we're going to try and wrangle. And so we have this values, and then I'm printing here the distinct name of the physical measurement and the unit, because I want to use a case statement, which is very useful for conditional wrangling. So I'm saying if any value in the column standard concept name lowercase has diastolic at all, then change it to diastolic, and it's called BP, blood pressure. And I'm also adding the unit, the abbreviated unit, so that I don't have to have 2 separate columns, because again, I want to turn this from long to wide. So I want a column that is informative of what's in there. And I'm doing the same thing for systolic, and then for heart rate and BMI, which doesn't have a unit here. Actually it does, and I didn't include it, but you get the gist. And I am here, this is why I'm performing a deduplication with a subquery. It's a little bit complicated, but not really. You can see that there's a measurement time, and AOU data is long format. For physical measurement, a person may have a multiple measurement of the same measurement on a day. So like, let's say they have, even for lab measurements, it's the same. They may have, multiple values of heart rate or whatever. So here I'm picking the most recent value with max per person per value. So there's going to be only one per person. Some people do averages. It's up to you as a researcher how you want to deal with that. And I'm just ensuring that I get only the people who have an actual value and a unit. And then let's see what that looks like after we wrangle it. And this is what we have, nice and clean. And this is what we're going to turn into our new columns with the pivot. The person ID as index, the measurement as a new column, and the values here as the cell values. And I already ran this. Let's run this. and see what that looks like. Okay, so this is nice and clean. If we didn't do the deduplication or wrangle the column names, we would get errors. Now, the last thing we're talking about before going to some more tips is just simply joining the table. So it's really easy with ProcSQL. You can just use an inner join to join two data frames. So I'm going to join my survey wide and my PM wide on person ID. And to do that, I can create a new table with ProcSQL. This is still SAS code. ProcSQL called survey PM. And then selecting all the columns in the joined tables. And then I just quit and run, and this is what we have. And actually, this is just a count. Let me run the first 5 rows. This is the first 5 rows of the joined data frame of everything that we've just wrangled. So my advice would be, actually, if you're trying to pivot data long to wide, if you don't need it row level, it's better to do a count data and then pivot. So let's say you would do count of participant per all of the variables and then pivot. That makes it pivot faster. But I understand that sometimes as a researcher, you need to pivot the data at a row level. So just make sure that you wrangle it before. Don't just go from this raw survey data here and try to do proc transpose. You might run into issues. So like deduplicate the data or remove variables that you don't need. Here, for example, I removed the survey variable. I did a drop somewhere where I removed the survey column that tells you whether it's by basics or not, because I didn't need that. I also removed the date time variable because I didn't need that. So just reduce your data frame as much as you can before you do the transpose. Okay, so that's the join table, and then you can again save it to the PD and then the bucket. And then this is code that helps us to see the total time it takes to run the thing. Okay, I hope that was clear and helpful. If there are any other areas of data wrangling in SAS that you struggle with or what you understand, we'll be happy to help include that in our resources. This is from the collection of questions that we had that I did this. Now, let's talk about some issues that, from my experience or our researchers' experience, that come up, and how so far how you can solve these issues, right? Or avoid them altogether. So we talked about a couple already. If the code is running too long, most likely it's not running at all. So close the program and open it back up. And then split your analysis into multiple files and then use the bucket to transfer the files in between. That will help with performance and avoid the files to crash. And then this error that comes up with creating a SAS environment, if that happens, and if there's some environment that was created or not, just delete that. You can close the SAS Studio, not RStudio application. Actually, yes, all right, that's right. Because SAS Studio and RStudio share the same computational resources. So if you have RStudio application running in the background, what's happening is SAS is trying to pull on the same resources to create an environment, which is already computationally intensive. So close that application. You don't need to delete the PD or anything. Just close it and then try to create the environment again after a few minutes. That should help it. And then we have this SAS service unavailable that happens sometimes. So it could be because it could be for many reasons, but typically just closing the program or the workspace altogether, and then you can log back in, should fix it. If it doesn't fix it after you do that a couple of times, then maybe the issue is more general. It's not just about your environment. Maybe there's something with the researcher workbench that is being fixed. So just wait a couple of hours or an hour and then come back and try again. Or you can contact us. And then this API error, this is pretty generic, so it could be many reasons, but I found that sometimes it's because for some reason SAS started me out and you wouldn't know because it wouldn't tell you sometimes on the page that you were on, but if you open a new tab, it would tell you, oh, you're signed out of SAS, and then you can just sign back in. So when that message pops up, there's an OK sign. If you click OK, sometimes it will just resolve the issue, or if it doesn't, then open a new tab or refresh your current tab here, and then sign in again. If you have code that you're running, maybe you can copy the code, paste it in a text pad or something, just to make sure you don't lose it, and then log back in. And then another thing is it takes a long time to initiate a SAS session. I would say some people say 25-minute plus. It typically takes me 15 to 20 minutes, but 25 minutes, I can believe that would happen. This is normal for the first time you create a SAS environment. It takes a long time, but once it's created, it shouldn't take that long again because to spin up your environment the next time. But you can try a few things. Again, if you have any R Studio application open, running, close that before you create your SAS session. And then if you're going to be using your SAS session or SAS Studio every day or so, you don't need to delete it after every day, right? Because what's going to happen is that you're going to need to recreate it every time and spend 20 minutes every time you want to open your file. So make sure that you don't delete that if you're going to be using it regularly. If you're not, then you can delete it. And then when you create the environment, pay attention to the default setting. That happened to me actually last night. I had created it and the default was 8 hours, so it deleted overnight and I had to recreate it this morning. So pay attention to that if you don't want to create it every time. Just make sure you change the default. I think it's right here. Yeah, I picked it one day for this time, but there's 30 days and all that. You can pick what's appropriate for what you think that you're going to be doing. And yeah, I think so far this is the things that have helped me solve all the SAS issues, and I was able to wrangle a huge data set, do some regression analysis and all that, and each of the files took maximum 6 minutes, so it's possible to do that. With that, we're gonna open with questions if you have specific questions for me.